Good morning. My name is Mark Roberts. I'm a solution architect at Red Hat in the UK. And this tech talk today is on image management with Red Hat Quay. And this is part of a series of tech talks that we've done from the UKI-Developers at Red Hat. It's a group of sort of like-minded developers who have an interest in technology, particularly around containers and development on Kubernetes platforms. And we run these tech talks periodically on specific technologies of interest. So look up UKI-Developers if you want a specific URL for our website to find our blogs and other videos. Let me know towards the end. So to begin with, let's start off with a containerized development cycle. And we start off very simply with some source code on the left-hand side. We're going to commit that into a Git repository. And then we want to build this in a container image. So we're going to use some form of builder image. We're going to build our application, compile the source code within a container, and then we are going to produce a new container image containing our deployable asset. So if it's a Java application of some kind, we're likely to have Maven tools and JDKs and other required technologies within that container image. And we'll run through that build and produce some sort of jar file, and that can either be stored on that container image and used directly from within there, or as part of a more involved build process, we might push that jar file or WAR file into a runtime image, and that's the thing that will be that new container image that we will use, store there on the right hand side, and ultimately to run. Now, ultimately, our builder images will come from a builder image library. Typically, that's held within the OpenShift platform itself if you're operating on OpenShift. And ultimately, we need somewhere to put these new container images that are produced. So those need to go into an image library of assets that we as an organization are producing, things that we might sell, things that we might just run within a production environment. And ultimately, we need to deploy out into QA environments. We need to deploy to pre-production. And finally, we need to deploy out to a production environment using those images directly from within that library. So ultimately, it's this image library that we're talking about today within this process. And if you've got questions around anything else around this sort of diagram, then let me know towards the end. We can have a chat about some of those things. But let's focus today on that image library. And if we think about the requirements for an image library, there are some essentials and then some useful to have. So the essentials are it needs to be secure. We don't want people tampering with our images. We want to know who has been pushing images into our library, because ultimately we're going to be using those in production. So it needs to be secure. We need it to be accessible from the clusters that will be producing the images, such as our development clusters, wherever they may be. And it needs to be accessible from our clusters that will consume the images, which could be in our own data centers, in a cloud environment, in a different cloud environment. So you might be spanning your development assets across various different cloud environments. You might have development in Azure. You might be running production in AWS or IBM Cloud or Google. You may have some on-premise private data center as well. And all of those need to access the same image library. We need an audit trail of change. So we need to know who did what, where, and when. We need to be able to answer those questions. And we want to be able to notify people and processes when changes happen, when new images are committed, when vulnerabilities are found. We want those notifications to fire. And we also want a role-based access control process. We want that fine-grained and easy to use so that we can control the access as necessary. Now, you might want it to be extensible so that you can interact with it via an API and build processes into automation processes that you have, things like pipeline processes. We're going to have a look at one of those in the demonstration in a few minutes as well. And you probably want it to be highly available and easy to use. Now, those are kind of the essentials, really useful to have. You might want to have image vulnerability scanning. Many people cover that process as part of their CI/CD pipeline activity. So there's a view there that their images are clean when they get into their library, because the CI/CD process includes vulnerability scanning. But what happens when those images effectively degrade over time? New vulnerabilities are found, new ways to exploit images are found, and those vulnerabilities need to be flagged. So if you have a container image that sits within your container library for a few months, new vulnerabilities might arise that you that you were not aware of when you built that container image. So vulnerability scanning of the assets that are held within the library is very useful. And you might want build automation and webhook capabilities directly within the library and move some of the image build and image generation processes into that environment. You might not want to host this environment yourself at all. You might want to have something that is hosted for you as well. So having a software as a service offering could be useful. So in walks Red Hat Quay. And this is a trusted image registry. It will store the images for you. You can run it on a Kubernetes platform. You can run it on premise or in a public cloud. And it's very easy to use and access. You can run it best on OpenShift. It's very, very easy to install. I did it on Monday on the development environment that we are using today for this demonstration. And it was very simple to install and set up and get running. We have global coverage of the platform, so you can access your repositories from anywhere, but likewise you can geo-replicate your repositories around the world, and we have an example of that coming up shortly as well. And you can run it as a self-managed platform. As I say, very easy to install on OpenShift if you want to manage all of those assets yourself, or you can go to key.io and you can use it there as a hosted multi-tenant platform. In fact, on key.io, you can store images completely for free if they are public. Obviously, your production assets that you use in your organization, you don't want to store like that. But if you want to experiment and try a few things out, you can create a few container images. You can store those in key.io and you can see how it operates. So beyond what we've done today, you can do some experimenting afterwards. So it really does support a complete DevSecOps environment. We have the build process whereby you can ingest images into the environment from anywhere that is appropriate, depending on where your development teams are located. And you can expose the images anywhere, depending on where they need to be used. You can locate all of that in one location around the world, or you can spread it around if you wish as well. And when it comes to shipping images, really, this is the question of, are we ready to deploy? Is this image safe? Should we be actually deploying this one out? So this is where we build in the vulnerability scanning that can take place on the images and highlight issues that arise, and all the notifications around that, as we said. And finally, the run. When we're running images that have been deployed into the environment from Quay, then the vulnerability scanning results can be exposed within the runtime platform itself. So there's a little screenshot there showing OpenShift. In the top right corner there, we can see some vulnerability information about some of the images that are being used. And there's a little bit more on that later on as well. So when you want to get assets into Quay, then there's a variety of ways that you can do that. You can pull images directly from the Red Hat container catalog. In fact, you might decide that there are assets in there in the container catalog that your team needs to use regularly. You want to stay up to date with those images as they evolve over time. So you can mirror directly from places like that. And Quay will poll that at an interval that you set. Might be every few minutes, might be every day. And it will pull in new images as required. So the mirroring capability allows you to pull assets from anywhere, not just mirroring between instances of Quay, between two instances of Quay. So you can pull from docker.io, you can pull from the Red Hat container catalog, and as the example shows there, you can push images in from Docker Hub, you can have your developers building images, and you can have your various clusters that you're using pushing assets into Quay. So Quay works best on OpenShift. So it's a layered process of building out the infrastructure. You have your OpenShift platform, which sits on RHEL Core OS, which sits in a cloud or on bare metal servers or on virtualization. And on top of OpenShift, we see Red Hat Quay. It's deployed as a series of operators. So it's extremely easy to install. The operator delivers a complete lifecycle management capability for the Quay instance that you're running. So that will take care of things like patches and upgrades over time and help you to manage it through the lifecycle of the product itself, regardless of the lifecycle of the container images that you're sitting within Quay. Now we have a couple of additional operators that sit to the side of that that also run on OpenShift that allow you to interact with it much easier. Now the CSO stands for the Container Security Operator, and that brings the key and vulnerability capability into the OpenShift console. What that allows us to do is identify the container images that are running on your OpenShift platform, identify the set of images that exist within the key repository for which we have vulnerability data. And if any vulnerabilities are found, it will then surface those vulnerabilities on OpenShift on the console. So one thing to point out here is that we are not doing vulnerability scanning of any of the images that are actually running on the OpenShift platform. That vulnerability scanning function takes place in key. It's just the fact that there are vulnerabilities that is pushed across into OpenShift through the container security operator that then allows us to surface those vulnerabilities in OpenShift. So we place in a very, very minute load workload on OpenShift to deliver that capability to you. Don't think that we're suddenly going to start hitting vulnerability scanning on running container images on OpenShift. The key bridge operator allows us to seamlessly integrate key with OpenShift and allows us to make use of images that are held within key much easier on the OpenShift platform. So let's look at that for a second and let's think about key as an upstream registry for OpenShift. Now I have a few moving parts on this diagram here, and the sort of left of the diagram at the top we have the Red Hat container catalog. That contains images that we want to use. It might contain things like the Red Hat UBI images, the universal base images, which are supported by Red Hat, produced by Red Hat, and contain base images that you can use with confidence. Now we're going to pull one of those into the Red Hat container platform to use as part of a build process. We're then going to go through a build and configure process, and we're going to push the resulting new container image into the OpenShift container platform registry. Now, every project will have a number of image streams that are used to store new images that are produced by the build process directly running on OpenShift. And we can then use those directly from within OpenShift. So ignore the bit that says Red Hat Key for the moment. Just focus on the push from the build and config into the OpenShift container platform, and then a pull into deploy that container image. And we have that then running on the OpenShift platform. Now we can extend that process slightly by having some automation process push some of those images from the OpenShift container platform registry into key across that line that goes from right to left into the app image area on key. We don't do that for every image in this particular scenario, because there will be builds that we test within our development environment that are not worth keeping, that contain errors that we don't want. So we'll only push across to key the images that are actually useful in this scenario. And then we can pull from those into this environment, into other environments, and use those images directly from key. Now, our other option here is actually just to use key as our image repository. So we've taken away the image repository held directly within OpenShift. In this instance, everything gets pushed to key, everything gets pulled from key. It's used as an integral part of that process, and it's used for all the images that we will produce. One of those scenarios will be more appropriate to you than the other, I guess. So now let's look at content distribution within key. And this shows two separate instances there in those big colored boxes at the top there. So we have a single instance of key, but we have localized storage. So our key master database and the image repository there is stored within the UK. So that's in that key instance there. But to accelerate the deployment of assets, we might have thousands and thousands of images to be consumed by our team in the US. So what we've done there is we have created a localized storage set of content within the US. And that allows us to effectively create a cache of content in the US. So we're pushing images into the UK there from the container catalog, Docker Hub, developer builds, developers in the UK. We have developers there as well in the US who are pushing into their localized storage. And that storage will reconcile itself between the two locations. The other option that we have is to do complete repository mirroring, which is what we've done there to our New Zealand team. So we have a separate mirrored instance of Red Hat Quay directly across there in New Zealand. That's a complete standalone separate instance of Quay. It doesn't have any reliance on the UK or the US for any of its assets. So that one will completely stand alone. So we have an option there of doing effectively a geo-replication of the storage, or we can do repository mirroring and create a completely separate instance. And here we're going to show you the difference between the two. So the geo-replication is designed for a shared and global registry where we have effectively one master instance, but we are effectively creating a cache around the world. The repository mirroring are distinct different registries, completely isolated. Now, if the replication and mirroring hasn't been completed yet with geo-replication, the remote copy is still used. So to go back a slide, if I push a new instance into the UK, a US user might try to use that image immediately the second I've just finished pushing it into the UK. And with that scenario, with the geo-replication, the US user will try to pull it from the localized storage. And if that doesn't work, it will be delivered from the UK. It will be a little bit slower potentially at that point, but it will still be delivered. Now, if we come back to this repository mirroring, I've only got my New Zealand image instance to look at. And if the image hasn't been mirrored to it yet, nothing's going to be served. Not a really big deal. To be honest, if the image isn't there, it's unlikely that people are going to go looking for images 4 or 5 seconds after they've been committed. And the image mirroring process can be done at whatever speed you want. Now, users can push images from both sides to the same repository. Well, that's a yes for geo-replication. You can push into any area that's been geo-replicated. With repository mirroring, that's not the case. If you push into one, it will only appear if it's been mirrored to the other location. The geo-replication is a complete identical copy of everything you have in Quay. With repository mirroring, that's not the case, but you get to pick what you mirror. So you get to choose the individual repositories that are sent out to that other location. So you can select individual repositories to be mirrored. You can select individual tags to be mirrored. So for example, you could decide that you only want to make available your production tagged images. And you do get different role-based access control with repository mirroring because it's a completely separate instance. So think about geo-replication if you want a complete 100% copy of everything that you have at a different place around the world. With repository mirroring, you get to pick the individual repositories that you choose to mirror. And I'll show you how you set the mirroring up in a few minutes' time. Let's talk about organizations and teams and users. Now, Quay has the notion of an organization. And the organization contains a number of image repositories that it manages. Each image repository contains one image, but it's multiple versions of that image. We identify those multiple versions using tags. So when we look at an image repository within there, we see the list of tags that it contains. And each of those tags refers to a different version of the image. Now, the organization has a number of teams. Now, teams consist of users and robot users. So automation users that can be used within pipeline processes for automatic push and pull of images. And that team, that grouping of users and robot users will have a specific role. Now, the role might be creator, so they can go and create new repositories. And that's not really associated with any particular image repository. There might be an administrator, and they can administer all of the repositories that exist within that organization. Or the role might say member. And if it says member, we then allocate permissions on a repository by repository basis. So you can see there that for repo 1, we've got none. We can't do anything with it. With repo 2, we have read access, so we can pull images. With repo 3, we have write access, so we can pull and push images. And with repo 4, we have full admin rights, so we can read, we can write, and we can manage that particular repository. So to give you an example, we have an organization on the left here called News Applications, and we have an administration team. And the administration team here has a number of users, and they have the role of creator and full administrator on all of those repositories in the news application. But if we now move on to a development team, they have a member-based per repository permissions, and we've allocated to our development team read and write permissions to all of our repositories there. So our UI, alerts, feeds, and reports, they've all been allocated read-write access. Moving on from our development team to our deployment team. Now this team only needs to read our repositories. They're not going to write new images. They don't need to administer them. So they're only going to read from those images. So that's the permission that they have there. So we have 3 separate teams associated with our news application organization: developers who can read and write, deployers who can read, and administrators who can do all of the administration across it. It's really easy to set up, and I'll show you that in a few minutes as well. Now, moving on to something called key build triggers. We can have a build process running directly within Key itself, and this allows us to take Docker files, and as a new Docker file gets pushed, we can then trigger off a build process. So we can be looking at a GitHub repository, a Bitbucket, GitLab, or a custom Git repository, and when someone pushes to one of those, then that will trigger off a build process within Key. So you might want to take advantage of that if you don't have automation processes already within the organization. Our Key repository images have tags. So multiple tags exist here. We've got version 8 going through to version 6 there. So the newer ones are at the top, the older ones there are to the bottom. And it shows us when they were modified, the security scan results. There's quite a few vulnerabilities there, the size, when they expire. And then we get this nice sort of grouping on the right-hand side with that 3 circles there, and the blue and the orange and the green. And what that's telling us is that those images are actually identical. Now they have a different SHA-256 hash there as well. An image digest is different. And the reason why those are different is because the digest is actually based on the tag as well. And the tags obviously have to be different. So yes, the image digests are not identical, so we can't spot images that are the same that way. But Key is aware of what images are actually identical, and it will highlight that with those green, orange, and blue bands shown there on the right. Now, you might make some changes to some tags and decide that it was the wrong thing to do. You might want to move, for example, the tag latest to particular images to allow people just to pull from latest constantly and get whatever version of the image you have decided is the latest one. But you might actually make a mistake and think, there was an issue with that image. We need to move latest back. So you can restore, you can roll back an image tag to a prior version over time, which is a great facility to have. So you can add new tags, you can move them around, you can delete tags, look at the history of all the tags of how you've moved them around, and roll them back as well if there's a particular issue found. Now let's move to vulnerability scanning, because this is really important. And there's a component within the Key solution, which is called Claire, and that's the Claire vulnerability scanning facility. So this provides us with this static analysis of the vulnerabilities that are found within the images that we hold. It gets a feed of new vulnerability data from Red Hat periodically, and it will then use that to scan across the layers of the images that are held. Now, as you know, images are made up of multiple layers, and Key will store layers very economically. So if it finds that it's pushing a new image and some of the layers already exist, it won't actually store them as new copies of the same data. It will just stop pushing them at that point, and it will just refer to them. And this helps with the vulnerability scanning, because if you have a base layer of an image that contains, say, a JBoss EAP server, then you don't want to scan that 100 times just because you've got 100 container images that use that particular layer within an image. In fact, you don't want to store that 100 times if you've got something that uses that 100 times. So we're very economical in terms of how we store the layers of the images. Also, that produces an economy of scale in terms of scanning them for vulnerabilities. But as you can see there, we've got some vulnerabilities identified, nicely presented, with information about how to remediate it as well. So telling you which particular version this vulnerability is removed in. And as mentioned earlier on, we have this fabulous container security operator, which allows us to feed information about vulnerabilities in running images up into the OpenShift platform. So this allows us to identify what's running. It takes a feed of data across into OpenShift from Quay and Claire every 5 minutes. You can change that to be less or more aggressive to suit, and it will allow you to visualize container vulnerabilities in OpenShift. And very briefly, you can get access to all of this image vulnerability information via a command line utility as well. So if you want to automate some of the analysis of this operation, and if you want to make some of this image vulnerability information available in other technologies, then you can do that. Okay, these are fairly long commands shown here, but they do serve as examples to show just how much information you can get out of that environment. And to have a look at what it looks like in OpenShift, there at the top right corner of the OpenShift screen on the left there, we see we've got one high vulnerability, and we can then drill across from that into the detail of that within Quay on the bottom corner there. Now let's turn our attention to notifications for a second. And within the notifications, we can trigger off various different notifications, such as email, notifications in the Quay web UI, web host posts, various others for events occur. So you identify an event, which is shown there on the right-hand side in that graphic, and you identify the threshold. So it's a vulnerability. Perhaps you might only want to report on a particular severity or above. And you might want to then identify the notification method, which will be things like email, key notifications in the UI, or a webhook post. And we also have a key API, so well documented using Swagger. So that will show you what you need to do within Quay to gain access to it from the API. So it's well documented. If you want to build things into the existing solutions that you have, then you can do that. Above and beyond this, of course, you do have the commands like builder, which I'm going to show you shortly, which are very easy to use to interact with Quay. And finally, we have container image management with these three utilities. And if you're not familiar with these, you might want to look these up afterwards to have a look at what these can do. Now, in summary, builder allows us to create new images. We can use Docker files with this. So the most commonly used sort of sub option for builder is -bud, which stands for build using Dockerfile. And then you point a Dockerfile at it, or -f Dockerfile name, and it will go and build that image for you. So it's a complete translation across from things that you might have been doing with Docker now, but of course Docker does require you to have some elevated permissions on your machine. Podman allows us to run images. So if you want to run something locally, not everyone can, because your images might need resources and assets and connectivity out to other assets across a microservice-based application. But if you can run something simple locally, Podman is a good way to do that. And that allows you to run the image and do all the things that you would otherwise have done with Docker. And Scopio allows you to copy images from one repository to another. You can view information about a container image without pulling it, which is really useful if you want to have a look at the description or information about a particular image. It can speed up that operation dramatically, and it can help us to do image management. The interesting thing about Scopio is it can help you to sign images as well. So let's go across now to Quay. So I'm logged in already. Let me just try and move this Ring Central window out of the way. So I'm logged in as user 1, as you can see there, just a general user within the environment. And at the moment, I have no assets stored within Quay at all. Now I can create new repositories that will sit just as things that I can manage kind of locally without being in the scope of an organization. But it's much better to group my repositories into an organization. And that's what I'm going to start with first. I'm going to create a new organization. I'm going to call this user1org. Let's go and create that. And within here, I can set permissions. I can create robot accounts. I can set default permissions for anything that gets created within here. So there's lots of things I can do. But let's go and create a new repository where we're going to store some of our container images. And I'm just going to call that one test. And I can make it either private or public. And in this instance, I'm going to make it public. Now, if I make an image public, it means that people can pull from that image without needing to authenticate into Key at all. If it's private, then you can control who can push and pull from it. So that creates my first repository, and it shows me the repository activity across a period of time. There's not much activity in here going on. We don't have any tags yet, which we'll create in a moment. We just jump across to key.io, where I have lots of images listed here. Let me just pick one of these. And immediately I go into that one, you'll see that we've got quite a bit of activity. If I float the mouse over one of these blocks, we can see that there were 2,294 actions on it on the 18th of December, 6 on the 24th, not surprisingly. So we've got a smaller number on specific days, but it just shows you there the days where probably we were running a Red Hat workshop and multiple people were using that particular image. So it gives us some good indication about how often it's being used. We can also look at the tags that exist on there. And as you can see with this one, we have multiple tags and we have some security vulnerabilities shown. But let's go back to the other instance of Key, which doesn't have any assets in it yet. And let's go back to managing our team. So now if we go back and click on repositories at the top, it shows me the structure. So here I have my organization, and then within it, I have a series of repositories, just the one at the moment. So let's go into that repository and let's think about user permissions. So I'm going to go and create some organizations now, go into the teams and membership and show you how easy it is to do that. Now we have an owners team already. It has one member, which is the person who created it, but it has no access to any repositories at the moment. Reason for that is because I created my organization first. So this team of owners was created before that repository arrived. So if I click on that, I can see who is within it, and I can go and change the repository permissions, and it shows me a list of repositories that I have. So what do I want the owners to be able to do to my test repository? Well, I think I want them to be able to administer it, do all the admin operations on it. So now the owners team has access to one repository. Now I'm going to go and create a new team for my developers. So I'll call this developers in here. And immediately it offers me all of the repositories that exist within this particular organization. Now I only have the one. I could use this to select them all, but I'll just select the one. And then I can choose to give it either read or write or admin permission. So I'm going to give my developers write access to that repository. Now that's given write access to one repository for my developers team, but there are no members of my team yet. So now I just have to go and say, well, who are the members of that development team? And in here, I can start typing a name and it will then prompt me for people who have that name. So I'm just going to add all three. And obviously you would have more sensible names in your list. If I go back now, we can see that we have 3 members. So it's really easy to create that. Now they have read access into that. Let's go and create a new one for our deployers.
Just a quick question about the access. When you're giving the read access, the write access, does it also include the read access implicitly, or do you have to also set up a read access as well when you do give write access to developers, for example?
No, the write access is for pull and push. So the write access includes the read access as well.
Cool, thanks.
Okay. Now, in this instance, these are my deployers that I'm creating right now. I don't want them modified in my images, so I'm just going to give them read access. And I'd probably go and assign other members of my team into that particular deployers group, but at the moment there are no members of it. Now, I can choose to set default permissions for any new repository I create. So what do I want to have? Well, read access I want to give to my, let's say I want to give that to user 3. So user 3 will have read access to any new repository that I create. And I can apply that to groups as well. So it's really good to be able to set up a set of default permissions, which means now I just go and create a repository and immediately the right people can push to it and the right people can pull from it. So let's go now to have a look at our repositories, have a look at test, and we have no tags. Now I want to push something into this. I'm going to move my screen across a little bit now. Let's get rid of that window. And I have a command line window here, and I'm going to use the builder tool. Now, hopefully all of that is still sharing okay. And you can see that I've run builder images, and I have an image there that I created quite a while back. It's 549 megabytes in size. And I want to push that image into my test repository here. Now, how do I do that? Well, I need to know where to push it to. And very helpfully, on the information panel of my repository, it shows me a Docker pull command. So I could just go and grab that Docker pull command and pull an image from there. Now, I don't actually want to pull the image. So what I want to do is push to it. So what I'm going to do first is I'm just going to grab this part of the URL. So it contains my server name up to .com. It then contains user1.org, the organization that contains this repository, and it then contains test, which is the name of the repository. So I'm going to copy that. And then over here, what I need to do is I need to use the builder tag command. Now I'm going to tag the existing image that I have. So that's the name and the repository name and the tag. And I'm going to retag that with this horrible long name, but unfortunately that's the name that's given to images that we have on our demonstration environment. And I'll add a new tag. Okay, and if I do build our images now, we can see that we now have that really long name. The image ID is the same, the size is the same because nothing has changed there. Now I want to push this image up into Key, but how do I authenticate from this command line window across here? Well, the first thing I'm going to do here is I'm going to go to account settings for my user. And on here, I have generate an encrypted password for the CLI. Now it prompts me for the password now to authenticate who I am. I put my password in. And then it offers me a number of ways that I can generate credentials for this particular user. Now, as an OpenShift user, I'm really interested in this one here. This is generating a Kubernetes secret. And I can look at that secret and I can download that and I can use that within an OpenShift platform to allow me to gain access from automation actions that I'm performing in OpenShift. So just by loading that in, I can then reference that secret directly from within automation actions I'm doing in OpenShift, and I can authenticate into Key. But for now, the one I want is, again, it says a Docker login command. Well, I'm not using Docker, I'm using builder. So I'm just going to grab this bit here from -u equals user, -p equals this password token, and then it's got the key URL on the end. So I'm now going to do a builder login command. I'm going to put an option on here called TLS verify equals false. Because I don't have as you can see, it's a non-secure instance up here on Key. I don't have a certificate on it, so I have to use TLS verify false and then put in that command from there. And then I'm now logged in. So great, that's logged me in. So now I can do a builder push. I still have to do TLS verify equals false. And I'm now going to go and grab the URL for the image, put the tag on the end. So I'm pushing that from my local builder repository that I have on my local laptop here, push that into key. And it starts to copy information there. Now you can see some information is already there as being skipped because certain layers already exist with other images on that platform. But if we go back now to the repository, now unfortunately we have to wait for home broadband to catch up. We look now on tags and do a refresh. There we have it. We have our latest image. And let's go and have a look at that now in a little bit of detail. So it tells us information about the manifest on the right hand side. We have the fetch tag across here. So if I want to use one of these images, I click on that. I then go to, do I want to pull by tag or by digest? Usually by tag. And there we go. There's a Docker pull command that we can use, or we can just grab the bit that comes up after pull, and we can use that with builder or put that somewhere else. We have the vulnerability information here, so let's have a quick look at that. And that shows us vulnerabilities. We can follow through a link there to more information from Red Hat about a specific vulnerability, which is useful to have. And it also tells us how to fix it and what version it's fixed in. So that's really useful information. And we can look at the layers that exist within this particular image. Now, the layers information shows us how it was produced, various things that have gone into it. But what's interesting here is that when I built this image, I attached a few labels to it. And one of those labels identify the Git commit ID that was used. And that's stored in a label called io OpenShift build.commit.id. Now it also shows the build commit author, the date, the branch it was on at the time, and so on and so on. But here I have something really useful because I'm looking at a container image. I might be a production person here who's figuring out what's gone wrong, or I might be reporting that there's an issue with this particular version of this container image. Now I can grab that Git commit ID there. I can go across to my project and I can do a Git show, and it will show me the lines of code that have changed, which is really useful. So by storing further information directly within the container image within labels, we have rich information that we're making available to our development team within that. So that showed really how we can push images in, how we can create repositories. I was going to show you the mirroring as well. That's really easy to set up. We just go down to the settings where we can see all the information about teams, users. We can set up notifications from within here as well, and we can look at the repository state, and in here we can set that to mirror if we want to, and then we go and specify where we're mirroring from and feed the information in. Now with just three minutes to go, I wanted to show you how you can automate some of these actions from within OpenShift, from within a pipeline operation. Now, you don't really want to be typing in those build-r commands by hand that you saw me doing in that command line window to manage images and move them around. You really want to feed that into a pipeline process. So I've got an OpenShift pipeline here. This is using the Tecton open source OpenShift pipelines add-on, which is added in by using an operator to install it into the cluster. And if we look at the details of that pipeline, we have a number of steps that we're going through. So we've got 6 individual steps. The first one is going to build a container image. Then we're going to do further processing on that container image, and we're going to deploy the application out. But the one that's really of interest here is pushing the image to key. So here I have a few build-r commands that I'm using there to tag the image, to look at the image, just to list them after it's been tagged, just out of interest, and then finally to push the image to key. And I can look at the commands that we use. So if I look at the task here and look at the task called push image to key, then I can look at the YAML for that, scroll that down to the actual commands, and there we go. So we have the steps within my pipeline using build-r tag that we saw earlier on, and some specific arguments there, variables being used to substitute in specific values. We then use the build-r images command to look at the list of images that exist, and we then use build-r push to push the images into the key repository, with variables in there for the key account, the repository name, and the tag to be used. Thank you very much for your time. I hope it's been a useful session. If you have any questions at all, please get in touch. My email is really simple. It's just mroberts@redhat.com. But feel free to reach out and get in touch if you have anything further. Thank you for your time.